Section 3.2, Law of Cosines. All right, we just finished section 3.1, which was Law of Sines. We said that you could use Law of Sines whenever you knew an angle and its opposite side, and then one additional piece of information. Um, Oop, let me scroll back up here. So for instance, you could know an angle, its opposite side, and then a side, an angle, its opposite side, and then an angle. Or you might know two angles and a side between them, but you can always find this third side if you know two angles. So you would know a side and its opposite side. So law of sines was for that situation. Law of cosines is every other situation. And law of cosines problems will only ever have one solution, which is nice. Law of sines problems, you could run into the ambiguous case where you have two sides and an angle. And that could run into so you could have two solutions, one solution or no solution, but law of cosines, only ever one. The two situations that happen with law of cosines is you could know all the sides and no angles, or you could know two sides and the angle in between them. Either way, you don't have enough information to use law of sines. The actual formulas for law of cosines are these guys here. They can be algebraically manipulated into each of these guys here. I just didn't feel like going through the algebra of explaining it, but the algebra is not bad to rearrange, solve for angle A, solve for baby A. This side right here is really just square roots. Take the square root on both sides. You know that side lengths have to be positive, so you don't have to do the plus or minus. The solving for the angles is just an obnoxious bit of geometry. I will allow you these on the note sheet. The very last page here, boop, the very last page here, you'll notice I did something nice here. I put all of the law of sines formulas here, so all the possible rearrangements of law of sines, as well as all of the law of cosines. And I will put these on the test. You can have these formulas. Okay. And by put them on the test, I mean you will be allowed that formula sheet on the test. All right, so law of cosines is for when there isn't a letter you know everything about. So let's say you're given angle A, baby B, and baby C. It's not like you can solve for angle B or angle C by subtracting two angles out of 180. So you just don't know you don't know everything about one of the letters. Same thing here, you know one thing about each, and down here, one thing about each. There are situations that look like they're law of cosines, but they're actually law of sines. Like this one, it looks like you have A, B, and C, so we shouldn't have to worry. Like that should be a law of cosine situation, because it is you don't know everything about any of the letters. But if you have angle A and angle B, angle C is just 180 degrees minus angle A minus angle B. So you really do have angle C. It's just a hidden angle C. And then you know everything about angle C or letter C, and you can solve using law of sines. Okay, so I just want to, for these examples, we're not going to solve anything. We are simply going to say whether or not we would use whether we would use law of cosines or law of sines, and if it's law of sines, do we need to check for a second triangle? So to determine this, because you're going to have problems on Alex where you don't, when you go to take a test, it doesn't tell you what topic you're working on. So you could be a law of sines problem, or it could be a law of cosines problem, and you don't know. Um, so here, A is equal to 8, B is equal to 10, angle A is equal to 30 degrees. You know everything about A. All right, I'm going to put no, no, everything about. Know everything about. I need a better word, but we're calling it Kia now. Know everything about. So maybe we should do capital KEA. We KEA know everything about letter A here. And because we know everything about letter A, that means we are going to do law of sines. We are starting with one angle, so it is the ambiguous case. And that angle is acute, so we do need to check for a second triangle. Second triangle. So law of sines, and we need to check for the second triangle because we are given one angle and it's acute. All right, this next thing, there is no letter we know everything about. We know A is equal to 5, B is equal to 7, C is equal to 9. There is no letter we know everything about, so this is a law of cosine situation. No letter we know everything about. So this will be law of cosines because we can't use law of sines. You need to have everything for one of the letters in order to use law of sines. Law of cosines, one solution only. All right, given C equals 12, B equals 8, angle B equals 130. Well, we know everything about B, so that's law of sines. No, Kia. Kia, know everything about B. So that means use law of sines. We are starting with one angle, so it's the ambiguous case. So that means 1, 0, 1, or 2 solutions. And I probably should have made a note of that up above. 0, 1, or 2 solutions. And the angle we're starting with is obtuse. So there will only either be no solution or one solution. There won't be two solutions because we're starting with an obtuse angle. So law of sines, where we don't need to check for a second triangle. Finally, side C is equal to 4, angle B is equal to 10 degrees, and angle A is equal to 52 degrees. Here, it doesn't look like we have everything, but because we started with two angles, we can easily find angle C. Angle C is just going to be 180 degrees minus 10 degrees minus 52 degrees minus 62 degrees. Angle C is going to be equal to 118 degrees, if I did my mental math right. So we do know angle C, right? Angle C was a very basic calculation. And now I know side C, I know angle C. So we know everything about C, which means we're using law of sines. We started with two angles, so there's only going to be one solution. So you do not need to check for another triangle here. And that's that. So just pay attention to these situations because you'll need to be able to differentiate between which times to use which. In the next video, we'll go over some examples and that's what we'll do. All right, I'll see you in that video. Bye.